What is going on, everyone? It's your boy G Money. Today I'm accompanied by our friendly neighborhood AI expert Bon Biscuit to discuss a research paper we both ran into, and it is called An Economy of AI Agents. And before we dive into this too much further, just a disclaimer that I am no economist, and I certainly don't think Bon Biscuit here is an economist either, unless he thinks so, Bon. I think he has his eyes closed. So safe to say he's not an economist. So do not trust everything that we say word for word. This is just an open forum. We're here to discuss. We're here to bounce off ideas and just think about the world and how it's being transformed as we evolve and the markets evolve and AI gets better. So artificial intelligence in the markets is not a new thing. This is something that quant firms and other trading firms have used historically to predict the market, for automation, for data analysis, and various of other things. But the picture that we're being painted now by especially the big, larger LLM vendors, so these are the OpenAIs, Anthropic, Gemini/Google of the world, who are pitching this idea of having our autonomous agents work for us. So an economy where autonomous agents are actually workers as opposed to a tool that humans use to accomplish tasks. So what makes an AI agent? I spoke about this in a recent talk that I gave, but there are fundamentally three things that I think agents do. One is they perceive their surroundings, so what is happening, they take input from various sources, etc. Two, they decide. So based on the input that they're getting, they make a decision. And then number three, they take action on that decision. This is what effectively makes an autonomous agent, where they can complete this feedback loops. So an example of an autonomous agent, a very good example actually, is Operator by OpenAI, which admittedly I've used it once or twice when it first came out, but there are just too many silly errors, or the timing was too long for me to permanently start using them on a day-to-day basis. So basically the core question comes to be, if we populate the markets and institutions and firms with these autonomous AI agents, will they actually be able to contribute one-to-one as humans do? As in, let's say you can just replace AI agents with humans in the economic models, or do we need another way of thinking about our economic models and come up with new ones based on AI agents? The next part of the paper, the authors explore alignment and opaqueness with AI agents and how they're not necessarily a one-to-one replacement for humans. And they outline kind of three main reasons which are quite compelling. The first part is we don't actually know what the AI agents underneath the hood are optimizing for. So they're trained on copious amounts of data. There's system prompts that are varying that we don't have access to. Ultimately, we truly do not understand the reward function of these AI agents. So how can we know what they're truly optimizing for? The next one, they talk about how their preferences and beliefs may not be well calibrated. Some research in the past have shown that LLMs are true optimizers, as in with enough loops, they do ultimately end up at the most efficient outcome or the most efficient solution. However, some other work show that the preferences can be actually quite inconsistent. And this is something that I feel like we've also experienced, where if you prompt some things a certain way, the expected outcome actually varies quite a bit. Finally, this is something that I've been personally thinking about for a long time, which is, in a complicated multi-agent architecture, how do we prevent the downstream catastrophe that could be if one AI agent decides to hallucinate or not behave as it should or as it must, and then downstream cause a disaster because these agents are tied in a network and one depends on the output of the others. So the alignment problem in this paper isn't just bound to, is the AI nice or will it cause the end of the world? It's speaking more from an economic angle, where it says, what objectives are these agents truly trying to accomplish? And what happens when you release millions of them in the market? And how do the economic models change, or how must they change based on that? And next, the paper talks about AI agents in markets and games. So the first one, it thinks about AI agents as consumers and producers. So in this case, imagine if your agent could be your virtual shopper. So this means that it is able to compare different items, leave reviews, negotiate prices, etc. And all of this is happening when we are asleep. And in theory, if you think about this, not just like from our perspective, but a perspective of the whole entire world that is now operating with their own agents that are making similar decisions for themselves, it sounds great. Especially from an economy perspective, it is more efficient, the search costs get lower, the transactions all of a sudden become faster, and it sounds kind of like a utopia that we would want to live in. And I personally know I don't want to go out and spend so much time shopping. It is actually an enormous waste of time in my life. And I would love to replace that with AI agents. But then with AI agents, there's always a catch, at least as the LLMs stand today. These agents are effectively trying to translate your nuanced details and preferences into higher dimensional space. And what that means is you cannot translate the nuance of your preferences and the details that you have as a human being. I can imagine, for example, for someone like my wife, who is highly detail-oriented about the way that she shops, I cannot imagine there existing a dimensional space where you can accurately represent what exactly her preferences are. And this mismatch effectively introduces two different distortions. One is you may end up getting goods that you don't necessarily like. And number two, if we think about the broader market and the economy and the world, the price equilibrium that we arrive at may not actually be reflective of what the humans ultimately want, but maybe more calibrated toward what the agent quirks are, like what are the LLM quirks, and maybe that is what it ends up being optimized for. And now, if we think about scaling this up into things like job platforms, dating, or other platforms where AI agents are actually searching for you, there are kind of two things that happen, right? One is they will make a margin of error. That means the preferences won't be exactly what you'd want, compared to, let's say, you just going on LinkedIn and searching for a job. Or the second one is when autonomous agents are hammering away at these platforms, then all of a sudden the traffic spike because these agents don't sleep. All the websites and these platforms that you're searching or deploying these agents onto, they're going to be congested and they're going to have to figure out how to handle the traffic coming from these agents. And next, the paper goes into talk about collusion and bargaining and game theory. And it almost made me wish we could have like kind of these simulation and experimental environments where we can test how AI agents might behave differently from textbook rational agents. Although this paper doesn't exactly outline the type of simulation and experiments we would run, it does present itself as a roadmap, and it frames the right questions to actually assess risks and dynamics like collusion, market distortion, with things like agent-based modeling, multi-agent experiments, or deployment data. And personally, I think this is going to be a very hard challenge because, again, like all the other points that we've mentioned in the past, which is the non-deterministic nature of these agents, the hallucination problem where if one agent ends up hallucinating, then the downstream agents also end up hallucinating because the output of one agent ends up being the input for the other agent. And it's going to have a massive network effect, especially if we're thinking about deploying agents at scale. So all in all, we need a new equilibrium for these agents because they are not one-to-one replacement, or they're not going to be a one-to-one replacement for human beings. And then next, the paper explores kind of a market of AI agents of their own. And then also it thinks about how will organizations today look with a lot of AI workers, and how does it change in terms of, do we have very large firms with a lot of human workers and then AI agents kind of like live alongside them? Or do we have much smaller firms where we don't really need that many employees working at a single particular firm, but we need a lot of AI agents that are working, and these employees are kind of just responsible for managing these AI agents. And this is something that is very interesting. Think about like having a marketplace where you can buy an AI agent that does, product reviews, that does searching for you on a job board, or does price negotiations for you as a company. Let's say you do procurement and you want an agent to do price negotiations. So you can think of these agents in a marketplace, and companies are going to buy and sell these agents. And it's going to look pretty typical to how software is being sold today. Similar to, for example, how SaaS is being sold today. And obviously there is a question of how do we price these agents. SaaS is something that we have over time really figured out how we do pricing for different type of SaaS. But with agents, how is that going to work? That is an open question. And what the economists in this research paper actually propose is the market is going to decide what kind of agents are going to end up being popular. So considerations that you could have are these open weight models or closed weight models? And when I say models, I'm talking about the underlying LLMs that are powering these agents. And that also brings up the question of like, are they transparent models, or are they kind of black boxes that we are seeing from these AI agents? And I guess when we talk about transparent and black boxes, we're not just talking about the underlying models and the weights that they come with. We are also talking about the underlying system prompts that these agents are prompted with. And then finally, what behavior that they like. If we do not see these underlying system prompts and kind of the objective parameters of these agents, are they going to be colluding with each other? Or like, what is their behavior going to be ultimately? And the economists propose here that the competition of that specific market is going to decide what are the agents that are going to be popular. And then they also look at kind of companies that exist today. Like what are the companies that exist today? What are they going to look like with agents that are able to work around the clock 24 hours, doing things like reading emails and responding to emails and doing kind of like vendor tracking and inventory updating. These are agents that are effectively working the jobs of employees today, and then the actual human employees, what do their roles look like? And in this case, things can be much smoother and much faster and potentially more efficient. And certainly you're going to get more number of hours of utility because these agents don't need sleep or they don't go back to their families. But on the flip side, what ends up happening is the hallucination problem, once again, going back to that, if we have one agent that makes a mistake, it can actually ripple through a network of agents. So we had discussed this idea that agents are still underneath the hood powered by LLMs, which are prone to hallucinations. In a multi-agent system, output of one agent is effectively the input of the other. And if one agent messes up, it can have a network effect that can make things go awry. In SaaS previously, we had monitoring software that can actually pinpoint, so things like APM tracing, network monitoring, infrastructure monitoring. They would actually give us signals and allow engineers and developers to track the root cause of things when they go wrong, like software that breaks or there are errors or there's latency. These are things that we had easy access to, first of all, X-ray, debug, and resolve. However, with agents, operators, which are humans that are operating these agents, may not necessarily know where things went wrong, and then they are stuck trying to debug the issue that actually caused a problem downstream. The power of companies may actually lie and concentrate on companies that can create the best agents and operate in a market where the competitive edge is solely based on how good can you prompt your agents or how good can you build multi-agent architecture and systems. And these are things that are going to impact kind of the market valuation and the valuation of the company. And AI agents entering the market can completely reshape how competition happens in any given market. So then once again, this question goes back to, it's very similar to like small LMs or large LMs are going to beat the market. Similarly, are smaller companies with specific domain expertise, are they going to be the ubiquitous one where we have multiple small companies running around and doing specific tasks with AI agents? Or are there going to be super giant companies that where they're able to build the best-in-class agents for any given task, and a lot of the investment and the market valuation is going to be concentrated around them? That is going to be an interesting question for us to answer as we go. And lastly, the paper touches upon the legal and institutional frameworks that market exist in today. And this is a huge topic because there are a range of questions. The questions span from if an LLM or an agent is the thing that is making mistakes in an institution, who is ultimately liable? And what does that liability look like? What about if you are in kind of a hybrid operating mode where your semi-autonomous agents are making the decision that run on some sort of an external entity that is outside of your institution? Who is liable then? And what about the developer of these agents? How is the autonomous agents misbehaving going to come back to the developers or the creators or the institution itself that are running these agents? So all in all, this points to a big question of like, do we actually need to rethink the legal framework that institutions operate in today? And the answer is likely yes. And the core design challenge here is that we need to allow beneficial use of agents while still making sure that we are incentivizing good behavior of the agents and honestly harshly punishing the bad behavior of the agents, such as collusion or anything that would expose you or your company to systemic risk. So in summary of this paper, there are kind of three main takeaways from my side. One is we need to start thinking about AI as not just a tool that people are using to accomplish a task today, but more of an actor in the economic system that we exist in. They are generating real economic activities, or they will as they get better and better over time. And the second conclusion that we've come to is that the standard models of economics are actually a great starting point in the world of AI agents, but we need to evolve them and we need to fine-tune them to fit in the quirks of these AI agents. And especially when we are thinking about the multi-agent system where there's so many error-prone pathways that we can travel down, these are going to need new thoughts and new design on the economic model side. And finally, the market and the legal side of things must evolve with AI agents because, as we just discussed, there's so many questions that today did not really exist because we didn't have autonomous agents kind of contributing so meaningfully to the economy and the institutions. We are going to have to rethink, how does law apply? For example, are developers liable for the downstream effects of AI agents and the multi-agent system going awry? In the paper, the authors don't really seem to claim to have an answer, which fair. We're just starting to go down this path as humanity. However, instead, they lay out a research agenda in this paper. Number one being measure and benchmark AI agent behavior. Number two being build new models for agent interaction and equilibrium. And number three being design institutions that are making AI-heavy economy safe, efficient, and aligned with human welfare. And if you are a scientist, if you are someone who works in AI, whether as a developer, product manager, whatever have you, and if you are a policymaker or someone who works in law, I think it is time for all of us to kind of sit down and discuss a real meaningful impact of this agentic world that we may soon live in, where AI agents are actually making meaningful contribution to the economy. Let me know what you think. If you read the paper, let me know if there are details that I missed in the comment section. Let me know if you'd like me to cover another paper that is very similar, or if there are other topics that are related to anything really, AI technology, that you'd like me to cover. And don't forget to like and subscribe, because I am just starting this channel and I would love any kind of a support and love from y'all. Thanks.